imagine for a second, right, that you are an astronomer.
Okay.
You've pointed this massive state-of-the-art radio telescope at a completely blank, just totally unremarkable patch of the night sky.
Just looking for anything out there.
Exactly. And for months on end, all you get is static. It's just random, chaotic background noise from the cosmos.
Which is pretty standard, yeah.
Right. But then, one night, embedded right in the middle of that static, you detect a sequence of prime numbers.
Oh, wow.
It's a pulse. It's blinking in this mathematical language that cannot possibly be an accident. Now, you wouldn't just shrug your shoulders and call it a coincidence.
No, definitely not.
You would immediately assume you were looking at intentional, intelligent design.
Exactly. You found a signal in the noise. And I mean, that is the foundational premise of SETI, right? The search for extraterrestrial intelligence.
Right.
They literally spend their days looking for patterns that simply do not occur by natural chance.
But what if I told you that today we are not pointing our telescope at the stars? We are pointing it at a 2,000-year-old book.
Which is a pretty wild pivot.
It really is. Welcome to the deep dive. We have a genuinely mind-bending stack of sources to explore with you today, mostly centering on a fascinating set of analytical notes and this really dense academic dissertation proposal.
Yeah, it's a lot to unpack.
And our mission for this deep dive: we are going to explore a theory that an ancient biblical text, specifically a story about some guys having a bad night fishing, actually contains a perfectly preserved, self-executing mathematical program.
Which sounds completely crazy at first.
It does. A set of hidden mathematical instructions that can be decoded using the exact same modern SETI signal detection techniques that astronomers use to look for aliens.
And look, I know exactly how that sounds. It sounds like pure science fiction or maybe some fringe internet theory.
Oh, totally.
But what we are going to see as we break down these documents is that the methodology being proposed here is remarkably rigorous. It operates within strict mathematical boundaries, and most importantly, it is completely falsifiable. This isn't about theology, It's about evaluating an ancient text through the lens of pure data science.
Okay, let's unpack this, because before we even look at the ancient text itself, I really need to understand how we are supposed to be looking at it.
Yeah.
The sources keep using the word steganography, and we need to clarify how that is fundamentally different from cryptography. Because cryptography is when you scramble a message, right?
Exactly.
You turn it into gibberish, so no one can read it unless they have the decryption key. But steganography is different.
Very different. Steganography is the practice of hiding the very existence of the message in plain sight.
So it's kind of like hiding the source code for a highly complex computer virus inside the plot of a children's bedtime story.
That's a perfect way to think about it.
If you read it, the words just look like a harmless story about a bear and a rabbit. You wouldn't even know there was a secondary layer of information there unless you specifically knew how to look for it.
That is a perfect analogy. And the theoretical framework in these documents proposes a 3-layer detection system to find that hidden code.
Okay, what are the layers?
First, you have the narrative layer.
Yeah.
That is the surface story, the actual text about the fisherman. Second, you have the algorithmic layer.
The actual instructions.
Exactly. These are the steganographically hidden instructions, the actual steps of the program. And third, you have the mathematical layer.
Which is what, exactly?
This is the ultimate output, right? It's a specific verification pattern hidden within the universal mathematical constant. And in this case, the constant is pi.
Okay, I'm with you on the 3 layers. But here is what I just don't get. Why use alien hunting tools? I mean, why are we dragging SETI into this? It feels like we are massively overcomplicating literary analysis. If an ancient author wanted to write down a math equation, why not just write down the math equation?
Fair question.
Why do we need astrophysical algorithms to read a fishing story?
So the reason SETI methods are so critical here is that they are specifically engineered for one core purpose.
Which is?
Separating intentional artificial design from messy, random background noise. And when you look at an ancient text, it is incredibly messy.
Right.
The narrative flows, the grammar shifts, words change based on context. It's not a clean spreadsheet.
It's full of static.
Exactly. It's
Gosh.
static. So how does SETI handle static? They use something called drift correction.
Drift correction, okay.
Yeah, in radio astronomy, if the signal is coming from a moving planet, the frequency shifts due to the Doppler effect. The signal drifts.
So SETI algorithms are designed to track that drift and correct it.
You got it. And when applied to an ancient text, this translates to looking for variable length encoding. The algorithms aren't looking for a rigid code like every 5th letter. because the story just doesn't work like that.
Right. It would ruin the grammar.
Exactly. They are looking for hidden information that structurally adapts to the flow of the narrative.
Ah, so the code kind of breathes with the story.
Precisely.
Yep.
The researchers also use SETI techniques to look for pulse trains, which are regular, unnatural intervals of data. And they use anomaly detection to find highly unusual distributions of numbers. We are literally taking the exact mathematical filters used to sift through galactic background radiation and applying them to ancient grammar and vocabulary.
And what we were looking for with those filters, according to the sources, is a key mechanism.
Yes.
The documents point heavily to something called the BBP formula. That stands for the Bailey-Borwein-Plouffe formula. Now, before reading this, I would have guessed that was a law firm.
It does sound like one.
But it's actually a massive modern breakthrough in mathematics from the 1990s.
It absolutely was a revolution in how we understand pi. For centuries, if you wanted to know the millionth digit of pi, you had to calculate the 999,999 digits that came before it.
Right, it was just a sequential slog.
Exactly. But the BBP formula changed that. It allows you to extract specific, isolated digits of pi without calculating any of the preceding digits. You can just jump straight to the billionth digit.
Right, and the implication of that property is just staggering. It means pi isn't just a random, endless string of numbers. It means pi acts like a structured memory lattice.
Yes, that's the key.
If you have the BBP formula, you can use it like a read head to sample a pre-existing numerical structure.
Right.
Wait, let's break down that read head idea for a second. Are we talking about, like, a needle on a record player?
That's exactly it. Instead of having to play the entire vinyl record from the first second just to hear your favorite chorus, the BBP formula lets you pick up the needle and drop it exactly at the 3-minute and 12-second mark.
Wow!
And the hypothesis here is that the ancient text contains an algorithm that functions remarkably like that needle. It's designed to drop into the mathematical constant of pi and extract specific data.
Okay, you've convinced me that the methodology makes logical sense. But a needle needs a record player. It needs a physical structure to operate within.
Right, a container.
So let's look at the container holding this supposed ancient code. The text we are analyzing is the Gospel of John, specifically chapter 21, verses 1 through 14.
The epilogue, basically.
Right. For context, this details the third time Jesus appears to his disciples after the resurrection. The disciples are out on the Sea of Galilee. They've been fishing all night. They've caught absolutely nothing.
Classic fishing trip.
Yeah, exactly. Then a figure on the shore tells them where to cast their nets, and suddenly they haul in this massive catch.
But as the documents stress, we have to strip away the theology here. We are solely analyzing the literary architecture. And this specific passage is built as a chiasm.
A chiasm. Okay, walk us through exactly how that works.
Think of a chiasm like a staircase that goes up, reaches a landing, and then mirrors itself perfectly back down.
Okay.
It follows a conceptual pattern. Point A, then point B, then point C. The landing is the climax.
Yeah.
Then it walks back down and reverse point C, then point B, then point A. The beginning conceptually mirrors the end, and everything points toward that central focus.
And in John 21, the center of this chiasm, the landing on the staircase, which sits at verses 8 and 9, contains very specific details.
Very specific.
It mentions a charcoal fire, and it specifies a distance. The boat is about 100 yards from shore, or exactly 200 cubits in the original Greek text.
Right.
But I've got to stop you here and play the skeptic for a second, because chiasms are everywhere in ancient literature.
They are very common, yes.
There are over 1,800 chiasms in the Hebrew Bible alone. Psalm 23 is a famously beautiful chiasm. Homer used them. So why is this specific chiasm being flagged as a secret algorithmic container? What makes this one so special?
It's a vital question. You were right that chiasms are incredibly standard for what we call semantic mirroring.
Matching concepts to concepts.
Exactly, or themes to themes, usually to help with memorization. But what makes the chiasm in John 21 entirely unique is its incredibly dense numerical anomaly.
Okay, what do you mean by numerical density?
Well, your typical ancient chiasm might have 0 numbers in it, maybe 1 if it's incidental to the story.
Yeah.
This single chiasm, crammed into just 14 short verses, contains 4 highly specific, deeply interrelated numerical parameters.
And the sources claim that because it's a mirrored structure, it acts as a addressable memory.
Yes.
I want to make sure I'm wrapping my head around this. In a computer, memory needs specific addresses so the system knows where to store and retrieve data. How does a repeated word in a poem act as a computer register?
It acts as a register because of the structural symmetry. Let's say you have a mathematical variable embedded in point B on the way up the staircase.
Okay.
Because the structure demands a mirror, that same variable, or a mathematically related one, must appear at point B on the way down. What this creates is a built-in error correction system.
Like a checksum in modern computing.
Exactly. It's a literal parity bit. Remember the SETI drift correction we talked about earlier?
Yeah.
This is it in action. If a scribe copying this text 2,000 years ago makes a mistake and corrupts a number on the left side of the chiasm, the mirror on the right side preserves the structural math.
Oh, that's brilliant.
The algorithm survives the static of human translation because the literary structure demands symmetry. It is a brilliantly robust, self-correcting code.
That is just wild. Okay, so the chiasm is the memory bank. It's the physical hard drive, but a hard drive has to hold actual data.
Right, the parameters.
So what are the specific parameters sitting inside this story? Let's look at the numbers, because this is where the math gets incredibly vivid. The text explicitly says the disciples catch exactly 153 fish.
Yep.
It doesn't say a lot of fish and doesn't say about 150. It's 153. And historically, everyone has known this is weird.
Oh, people have obsessed over this number for centuries.
St. Augustine thought it was a code and pointed out it's the 17th triangular number. Jerome thought it represented all the known species of fish, meaning all the nations of the world.
Right, theological explanations.
But the dissertation proposal takes this way out of the realm of theology and plunges it straight into ancient Greek geometry.
Yes, and this is where the puzzle pieces really start snapping together. Centuries before the Gospel of John was ever written, the brilliant Greek mathematician Archimedes of Syracuse was working on approximating the value of pi.
Okay.
He didn't have calculators, obviously,
Yeah.
so he established the bonds of pi using complex polygons. And in doing so, he had to calculate the square root of 3.
And how did he do that without decimals?
The fraction he used to represent the square root of 3 was 265 over 153.
153. There's our number. And the sources point out that Archimedes reportedly called the number 153 the measure of the fish. Again,
Yes.
centuries before this fishing story even existed. And it ties beautifully into a concept called the Vesica Pisces.
Right. The Vesica Pisces is a piece of sacred geometry. If you take two identical circles and overlap them so that the edge of one passes through the center of the other,
Like a Venn diagram.
exactly like a Venn diagram, the almond-shaped area in the middle is the Vesica Pisces. In Latin, that literally translates to vessel of fish.
Okay.
And the geometric height-to-width ratio of that shape is exactly the square root of 3, which, as Archimedes established, is the ratio of 265 to 153.
I just need to pause and appreciate that for a second. To an ancient Greek mathematician, the number 153 wasn't just a random head count of a fishing catch.
Not at all.
It was a neon sign. It was a highly specific geometric coordinate pointing directly to the math used to calculate pi.
That context is everything. We have to remember that ancient Greeks did not use modern decimal notation. They didn't write out 3.14159.
Right.
They communicated high-level math through fractional ratios and geometric constructions. The author of this text is speaking the advanced mathematical language of their specific era.
And 153 isn't even the only number. We have 7 disciples in the boat. 7 is the 4th prime number, which the notes suggest serves as a mathematical modulus, or like a base.
Yep.
Then we have the distance to shore, 200 cubits. That sets a geometric scale. But here's where I got a little lost in the reading.
Okay, where did you get lost?
The notes say that from the 200 cubits, we are supposed to take the square root, which is 14.14, and that gives us the size of a grid. Wait, hold on. Why are we suddenly taking square roots?
Ah, I see why that's confusing.
Who decided that was the rule? That sounds totally arbitrary to me.
It sounds arbitrary to a modern listener, sure, but to an ancient geometer, it is perfectly logical. In ancient Greek mathematics, a line value like 200 was often used to represent the area of a square.
Oh, the area?
Right. If you want to build a physical grid out of that area, you have to find the length of the sides. How do you find the side length of a square with an area of 200?
You take the square root.
Exactly. The square root of 200 is 14.14. So the text is implicitly handing you a 14 by 14 grid.
Okay, that actually makes sense. It's not arbitrary. It's following the rules of the time. So let's take inventory. We have a collection of variables sitting in our boat.
Our preloaded parameters.
Right. We have 153, which is our pi indicator. We have 7, our base. We have 200, our data set size, and an implied 14.14, which gives us our grid.
Yep.
In a normal book, this is just a hyper-specific, somewhat obsessive level of detail. But if we are treating this as steganography, these aren't details. They are variables waiting to be used.
Correct. They are the parameters for an extraction algorithm.
So how do we turn the program on? What is the enter key for all these variables?
Well, there's a direct physical command in the text.
Right. The figure on the shore tells the disciples, cast the net on the right side. Now, in ancient math and navigation, moving to the right side implies a positive angular displacement. It means a clockwise rotation.
And that command is the catalyst. It is what triggers the extraction algorithm, which the sources call the SETI protocol.
Okay.
The documents outline a very deliberate 5-step sequence that uses absolutely every parameter we just discussed.
Let's walk through this slowly because I want you, the listener, to really visualize this geometry. Step 1.
Step 1. You take the first 200 digits of pi. The number 200 is provided by the 200 cubits of distance.
And the pi is from the fish?
Exactly. The fact that we're using pi is signaled by the Archimedes fraction of 153 fish.
Got it. 200 digits of pi. Step 2.
Step 2. You take those 200 digits and you place them into a 14 by 14 grid. We get the 14 from taking the square root of the 200 cubits.
Okay.
A 14 by 14 grid gives you 196 individual cells, which almost perfectly houses those 200 digits.
Okay, so we have a square grid filled with the numbers of pi. Step 3.
Step 3. You need a starting position. You don't just start reading at the top left corner like a normal book.
Where do we start?
You start your sequence at coordinate 7. 7 in the grid. That is the dead center of the square, and it represents the 7 disciples sitting in the boat.
Step 4. We have our starting point. Now we move.
Step 4. You execute the spoken command, cast the net to the right. Starting from coordinate 7, 7, you map those digits of pi, moving in a continuous, clockwise, spiraling outward direction.
Like drawing a maze?
Kinda, yeah. In modern mathematics, this specific pattern is known as an Ulam spiral, and it is famous for revealing hidden geometric patterns in prime numbers.
Okay, so we are drawing a spiral of pi digits in a box. And finally, step 5. What are we actually looking for?
Step 5 is finding the target data. The narrative explicitly closes by specifying that this is the third appearance after the resurrection.
Right, the number 3.
The number 3 is the thematic climax. So, once your spiral is drawn, you isolate and look at the physical distribution of the number 3 within that grid.
Okay, let me just stop and take a breath.
It's a lot.
We build a square grid based on the distance to shore. We start at a central coordinate based on the number of men in the boat. We draw a spiral outward based on the direction they threw the net.
Yep.
And we populate that spiral using the digits of pi, which was signaled by the specific number of fish they caught. And then we just look at where the 3s landed. What exactly are we hoping to see?
This is where the science actually happens. This is the null hypothesis.
Okay.
We are looking to see if the physical distribution of the 3s in this highly specific grid forms a non-random pattern. Does it form a perfect geometric symmetry? Does it visually draw a shape that validates the third appearance motif?
And if it doesn't?
If the 3s are scattered totally randomly, like static on a TV screen, then the null hypothesis holds true. The algorithm failed. It means the narrative is just a story, and our human brains are just over-patterning.
And that brings up the massive glaring elephant in the room. I know exactly what you were thinking right now as you listen to this.
The Bible codes.
Yes. Isn't this just another debunked Bible code conspiracy? The 1990s were full of people claiming they found secret messages about modern assassinations hidden in ancient texts. We really need to explain why the SETI methodology is fundamentally different and why the sources insist this is rigorously scientific.
To understand the difference, we have to talk about a concept called the Texas sharpshooter fallacy.
I love this analogy.
Imagine a guy walks up to the side of a barn with a shotgun, closes his eyes, and fires. Then he walks up to the barn with a bucket of paint, finds the biggest cluster of bullet holes, and paints a bullseye right around them.
And claims he hit the target.
He steps back and claims he's a master marksman. But really, he just defined the target after the data was already generated.
That is exactly how those old Bible codes worked, the equidistant letter sequences. They had an infinite, entirely unbounded search space.
Completely unbounded.
They would take the original Hebrew, skip every 50 letters, find nothing. Then they'd skip every 419 letters, then they'd read it backwards, then diagonally.
Just changing the rules.
They would just keep manipulating the parameters until they accidentally spelled out a famous person's name. And then they'd paint the bullseye and say, look, a hidden prophecy. It's completely unfalsifiable because if you don't find a pattern, you just change the rules until you do.
Exactly. It is pure post hoc pattern fitting.
Yeah.
But this method, this disaganographic algorithm outlined in the dissertation proposal, operates on strict Popperian falsifiability.
Which means?
Karl Popper argued that for a theory to be scientific, it must be capable of being proven false. In this experiment, the parameters are not made up after the fact. They are pre-specified by the text itself before the search even begins.
The text forces your hand. You can't just decide to use 500 digits of pi because the text explicitly says 200 qubits.
Right.
You can't use a 20 by 20 grid because the area dictates a 14.14 side length. You can't just start at coordinate 2, 2 because there were exactly 7 disciples. The search space is entirely bounded by the narrative. You have one shot.
Furthermore, the data source itself, the digits of pi, is completely external to the text. Anyone in the world with a computer can independently verify the digits of pi.
Right, the text isn't giving you the data.
Exactly. The ancient text is merely providing the lens, the extraction sequence, to look at an external, universal truth.
I love this because it proves the methodology. If we ran this exact same 14 by 14 Ulam spiral sequence using the mathematical constant E or the golden ratio instead of pi, or if we decided to start at coordinate 5 instead of 7, and we found absolutely nothing but random noise.
Which is what you'd expect.
That actually proves the method works as a scientific test.
Yeah.
The fact that it can fail, and fail spectacularly, is what makes it legitimate science.
And that raises the final, most crucial point of analysis: joint probability. Statisticians use joint probability to look at the compounded likelihood of multiple independent events occurring together by pure chance.
Right. What are the actual odds of all this happening accidentally?
Think about it. The chances of 153 being a known Archimedes denominator, plus the Vesica-Pisces height ratio linking perfectly to the fish.
Plus the square root of 200 creating a perfectly sized 14.14 grid.
Plus a specific clockwise rotation instruction, plus an addressable third index position. All of this living organically inside a self-correcting chiastic memory structure.
It's insane.
The probability of all those distinct variables aligning perfectly to execute an Ulam spiral without intentional design is multiplicatively tiny. It is that infinitesimally small probability that justifies the suspicion of design.
Right.
It is exactly the kind of anomaly that tells the SETI astronomer to stop scanning the sky and focus all their attention on that one specific blinking pulse.
It is the wow signal, but written on ancient parchment.
Absolutely.
Okay, let's pull back and look at the journey we've just taken. We started with what looks, on the surface, like a simple, completely ordinary story about some fishermen having a rough night on the water.
Just a normal narrative.
But by slowing down, looking at the structural anomalies, and applying the exact same drift correction filters that astrophysicists use to look for alien signals in deep space, we uncovered what appears to be a highly specific, pre-programmed geometric algorithm.
An algorithm deliberately designed to extract and map coordinates from the universal mathematical constant pi.
And we really must remember why a theory like this matters so deeply.
Right, the big picture.
Regardless of whether the final pattern in those threes turns out to be a perfect geometric shape or just random statistical noise, the framework being proposed here fundamentally challenges how we are supposed to read historical documents.
It forces us to ask a staggering question.
Did ancient scholars, knowing full well that papyrus rots, that libraries burn, and that empires fall, actively embed high-level mathematical knowledge inside culturally persistent narratives just to ensure that knowledge survived the centuries?
It's the ultimate time capsule.
They couldn't pass down a hard drive, so they passed down a story that operates exactly like a hard drive. It really makes you realize that when we stare at the seemingly random static of history, we might not just be looking at noise. We might just not have built the right telescope yet to see the signal.
That's a great way to put it.
Which leaves you with a final thought to mull over long after this deep dive ends. If an ancient author successfully managed to hide a perfectly executable mathematical extraction algorithm inside a simple story about catching fish, what other narrowband signals might be ticking away, hiding in plain sight within the classic text we assume we already understand perfectly?